Hi, everyone. Today, what we're going to work our way through is how we apply what we've kind of learned up to date, specifically dealing with polynomial functions and equations. So, what you have on the screen right now in front of you is you have an application problem that's going to deal with a polynomial setting. What I want you to do, pause the video, give the problem a read, try to make sense of the problem, and I actually want you to try to solve this whole problem on your own. I think you have everything in your background to be able to solve it on your own. I'm going to go through, I'm going to put up a solution to the problem, we're going to talk about how we build it, and then I also want to spend a little bit of time talking about how you would be evaluated on such a solution. Okay? So, pause the video now, give it a shot. Okay, and we're back. So, to start off this problem, we recognize we have an open top box. It's going to be made from cutting squares and then folding up the sides. Now, if we have a tough time kind of envisioning that, imagine that where I'm putting these dotted lines is actually going to represent the creases that we would make as we were to fold up those sides. So these blue squares in each corner would be eliminated, and it's like we would fold up the flaps to then produce our open-topped box. So the question asks us, what are the dimensions of the square that must be cut from each corner? So we need to describe, like, what's the length and the width, since it's a square, that's the same thing, for each one of those blue squares that are going to be cut and removed. Okay, how can we start off the problem? Well, we're going to go through a series of pauses in this video. So now that maybe you understand the concept, if we struggled in this application, maybe now pause the video, give it a shot. Okay, so we're back, and now we're going to work our way through. Well, one of the strategies that you can come up with to be able to go through and solve problems is, like, if the question asks you, what are the dimensions of the square, then sometimes making that your variable, what the question asks you for, can be a good strategy. Then when we solve our equation, we've solved for that variable, you've answered the problem that was asked. So maybe I start off in this case, and I'm going to say that I'm going to label the dimensions of that square x. I don't need to label both of them because they are squares. That means that they are the same thing. I would suggest, though, putting on at least a little tick mark for each one of those. So, if I'm going to solve a problem using any sort of algebra, then I need to define a variable. And what you just did in green there is sufficient. You defined your variable. Because the problem is an application question, it deals with a shape, because it's a measurement problem and it deals with a shape, then draw a diagram, label it on your diagram. That is perfect communication. You've defined your variable. Or you're going through and you're saying that you are going to let x represent the dimension of the square. I don't need both greens. If you've labeled the x on your diagram, you are perfect. So, since I don't like writing let statements, even though they're absolutely necessary, in this instance, me labeling my diagram is just as good as a let statement. I am good. There's my x. Okay, now that I've done that, what else can I label on the diagram? Well, I'm cutting out the squares, so I would really love to know what is that length, since that's going to be one of the dimensions of my open top box. Well, I can start off with them. What was the dimension of the actual piece of cardboard in the first place? And what we have then is we've been told in the problem that it's 30 by 20 all the way across in the original piece of cardboard. However, now that I've cut out an x from each corner, I've actually found that this dimension in here is 30 minus 2x's. It is the whole distance of 30 all the way across. Take off an x on one side, take off an x on the other side, and it's been shortened. If we're good on that reasoning, then we should be pretty good to say that this inside dimension would be 20 minus 2x for the same reasoning. And now that I have those inside dimensions, I can actually talk about the other piece of information that was given in the problem. It told me that this remaining box will have a volume of 1,008 centimeters cubed. So now I can build an equation to represent that case. Okay, if we were stumped up to that point and we were unsure how to get going, pause the video now and try to finish off the problem. Okay, we're back. So for us to calculate the volume of a box, we know that volume is going to be length times width times height. And so I'm going to plug in everything I know. Okay, I know that my volume is 1,008. The length of the box would be a 30 minus 2x. My width of my box would be a 20 minus 2x. And when I flip up those flaps, what I am highlighting in red right now on that right side is going to represent the height of my box. So what is the dimension of that height? Well, it's the length of the square. So it's an x. And I have now built my equation ready to solve. Okay, if we struggled to build an equation, now we've turned this problem into a knowledge problem. We should be good to be able to finish this thing off. So pause the video now, give it a shot. Okay, so we're back. So in this instance then, maybe we're motivated, we don't see any pattern really inside the brackets. We're going to go ahead and we're going to expand the brackets and collect like terms. So I've got my 1,008. What I end up getting in this case is a 600 when I expand, and then expand in that extra x. I'm then going to have a middle term of a negative 60x and a negative 40x, which is a negative 100x. Expand in the extra x. And I'm then going to go through and expand in, and I've got my negative 2x times my negative 2x, which is a positive 4x squared. Expand in my extra x, oops, and it's a cube. Okay, we get to that point. We see that we can't put our x's together into one variable term. So let's write that in standard form with everything on one side of the equal sign, so we are equal to 0. And there we go. So that's going to look like a polynomial equation that you've spent some time solving. Okay, if we struggle to get down to that point, now I want you to pause the video and try to solve that equation. Okay, we're back. So a couple things first off as we go through to solve. The first thing is you always want your numbers to be as easy to work with as possible. And hopefully we took a peek at that and we noticed that every single one of those terms has a common factor of 4 in it. So I'm going to spend a line and I'm going to divide out that 4. So if I divide the first term by 4, second term by 4, third term by 4, and my fourth term by 4, so if I multiply my 100 by 4, then that's a 25, and my 8 by 4 is a 2. We should get down to that. Okay, it doesn't mean that all of a sudden that black equation is easy to solve. It's still pretty ugly because we're going through the process to try to solve that equation. Pretty quickly, we should recognize that it does not factor by grouping. And so we're stuck testing our factors of 252 to try to use factor theorem. Hey, at least that's better than 1008. So pause the video now, see if we can test that out. Okay, we're back. So hopefully we snuck in a little equals f of x somewhere on that line to name that equation. And if I go through my process of subbing in a 1, well, 1's going to be pretty difficult because it's not going to get those things to cancel out. Maybe 2 works up. Like 2 might not be too bad. If I was just to check off the top of my head, like there's an 8 and a 100. I then get to a 300, but as soon as I subtract off my 252, I can see that those are not going to cancel out. So now maybe I'm jumping in and trying something. Maybe I get up to my 3. And if I do my substitution of 3, then if I cube my 3, I'm going to square my 3, which gives me 9. 9 times 25 is 225. If I multiply 150 by 3, I get 450. And if I subtract off my 252, you might see that that actually gives us a 0. We love that 0 because now that's what allows me to say that x minus my 3 is a factor. And there we go. So we now have that problem set up. We should be good to be able to finish off that problem in dealing with factoring. So I want you to pause the video now and see if you can finish off the problem. Okay, and we should be back. So what I'm going to do is I'm just going to jump over to the next page because this problem does become pretty mechanical, at least for a while. So what we found then was that we had this equation and we just found that x minus 3 was a factor. And so I can go through the process of comparing coefficients to be able to get back to a factored form, or sorry, to be able to get to a factored form from that original equation. So I can see that I'm going to multiply x by an x squared to get back to an x cubed. What would I multiply 3 by to get back to 252? Well, 252 divided by 3 is going to be an 8 with 1 left over and a 4, so 84. That needs to be a positive to get back to that negative 252. And now as I partially expand, there's my negative 3x squared. I need negative 25x squared, so I need to include another negative 22x. So we get to that point in our equation, and now we can start to solve. I can tell from the first factor that x equals 3 would be a solution. But my second factor, I don't think that thing is going to factor further. Now, this is where we come into a kind of a mode, a decision we have to make. What would you be faster with? Would you be faster to just jump in and use quadratic formula? Or, because factoring is faster, are we quick enough to be able to check a couple combinations and see, and then if not, jump over to quadratic formula? It's really your call. It's a personal thing. So pretty quickly, like I see that 84, and 84 is going to be, okay, so 42 and 2, no way. 21 and 4, nope. I can get to a 7 and a 12, nope. Okay, I don't think that thing factors. And so I jump into quadratic formula. So my x equals negative b plus or minus the square root of, well, now I got to calculate 22 squared, so that's a 484, minus 4 times a times c. So I have my 4 times 84, so 4 times 80 is 320, 4 times 4 is 16, so that's a 336, all over 2. I would suggest that to be your first line. And then we can clean it up 2. 484 minus 336 is a 150/48 all over 2. Now, how do we finish off this problem? Okay, take a look at the black equation I put up on the front, or on the very top. If I had given you that equation and asked you to solve, then the expectation is that we're going to solve that for exact values, and you would now be taking 148 and you would be doing a little factor tree like, hey, 2 times 74, and then break that up into 2 times 37, and so on to be able to give me an exact value. However, I didn't give you that black equation. You created that black equation from trying to solve an application question. And so when I ask you, what is the dimension of a square, if you were to give me 11 plus root 13 halves units, people are going to look at you weird. That because we are working with an application problem, I don't even know if it's acceptable, but it's common practice to give an approximate answer. And so we don't need to do any of that black factor tree off on the side that you guys can go through and you can calculate your approximate values right now. The only rub becomes round as little as possible. So nobody should be calculating what root 148 is, rounding that off, then doing your plus or minus with your 22, divided by 2, and then potentially rounding again. No one should be doing that. Instead, what you're going to do is you're going to go ahead and you're going to calculate the whole thing in one go. So let's calculate the addition option first. Calculate your 22 plus root 148, divide that by 2. And in this instance, there's been no rounding rules that have been described to you. There's also been no inherent rounding rules. Like there's no rule that says how many decimal places do you have to go through and round a side length of a square. It's not like it's money and therefore we default to 2 decimal places. When there is no rounding rule stated and no inherent rounding rule, then we're going to round to 2 decimal places. So if I was to calculate, there's my approximate. You see the dot above my equal sign. I'm going to round this to 2 decimal places, and I should get 17.08 for the plus. And let's just make sure that we're good on our keying sequence again. I want you to pause the video right now, go through and calculate what your minus case should be. Give it a shot, see what you can come up with. Okay, I'm hoping that we're back, and you guys were good to then come up with your 4.92. And there are 2 solutions. Okay, now that we found our solutions, you have to ask yourself, have you answered the question? And let's make sure that we take a quick peek on the solutions. I want you to pause the video now, make any changes to your solution that you need to, and we'll come back. Okay, so as you took a look at those solutions, I'm hoping that we made one adjustment. Keep in mind, and I'm just going to draw the diagram up on the right side again, just so we have a sense of what we're talking about. This was our overall piece of cardboard with those little squares chopped out of the sides. So now that we can see everything in one spot, are you good with this side possibly being 3? Hopefully we're okay with that. And so we feel, okay, that's a pretty good solution. Are we good with this dimension being 17.08? And I'm hoping that once we see that, we say, okay, that can't happen. 17.08 is way too big. Keep in mind that that whole length all the way across the bottom was 30. And we're now going to subtract off a 17.08 from one side and then another 17.0. we don't have enough cardboard to subtract off our two 17.08s. So if we recall, that 17.08 is a solution to the equation. However, it's not a solution to the application. We can't accept it. And so therefore, we label it as inadmissible. And there you go. So are we okay then with the 4.92 being a dimension? And I'm hoping that we go, yeah, that's possible. I can subtract off a 14.92 from even my shortest side of 20. And that works out. So is it possible then to have two different dimensions of our squares that give us that volume? Sure. You know, if I subtract off a small amount, then maybe what I have is like a shorter, wider box that has a volume. But if I subtract off a little bit more, then maybe what I have is a taller, thinner box that still has that same volume. I can accept both. Now, in this instance, because we had a case of an exact value and a rounded value, we should be putting a therefore statement. And so, therefore, the square can be, now we exactly are 3 centimeters by 3 centimeters. Or we have this rounded situation on the 4.92. So the way we often say that is or about. You know, you could write in approximately 4.92 centimeters by 4.92 centimeters. Put your units on, and you've got a perfect solution. Okay, there is our entire problem. There is your solution to it. I hope that things were good. The only last part that I want to talk about is how would we mark this sort of solution? If this was a test situation, how will this be evaluated? And so to talk about how this is going to get evaluated, I think the biggest part is to be able to look back to the top. So I've put back onto the screen the beginnings of our solving, because I think that's really where the meat is. I want you guys to notice that as you look at this, there's only a little bit of this problem, at least in terms of the full solution, that is application. I'm going to just highlight what that application is, and it's pretty significant. If I had to go through that first line that I just highlighted in blue, that is your application. Like you read the question, you kind of set up the problem, and you worked your way through to that. That application stems from the fact that you also knew, okay, I can label my one side as an x, which will then generate these other dimensions of 30 minus 2x and 20 minus 2x. What I just highlighted in blue, that is your application. If you start to look at the rest of that solution, you're going to notice that a lot of that is just straight knowledge. So if I was to jump through then and highlight that in like a different color. So I'm going to go through and I'm going to highlight that in green. Then this whole process in green. Then this whole process of expanding the brackets, collecting like terms, dividing out a common factor, that's all just algebra. That is your knowledge-based stuff. Well, you using factor theorem to be able to go through, that doesn't have anything to do with the application question itself. Like, that's all straight knowledge. That we don't even have to look at the end of the problem. You going through then and factoring your equation, then using quadratic formula, then finishing off that statement, it's all basically knowledge. So let's say then that this problem happened to be a 4-mark question. So off on the side, you saw it was out of 4. This first line is going to be at least out of 2. At least 50% of the problem, because that is the application. Then all the rest of your algebra, probably, you know, expanding your brackets, collecting like terms might be worth like another half a mark. Dividing out your common factor, being able to go through and solve, you know, factor theorem, the meat of this course, like that'll be worth like probably another half. To get down to your factored might be another half. To then use quadratic formula might be another half. And then that basically gets us up to our 4. And so that may be a little bit different for you guys from the past. That maybe we made a mistake creating the first equation and maybe you only lost like a half a mark or a mark on it. Guys, the application is the important part of this problem. That's why it's on the evaluation. It's going to be the meat of the marks on that problem. Okay? Hopefully that gives you a little bit of an overview of what an application question would look like in this unit, and then also a way that we're going to evaluate it. Okay, your job, jump in, get some practice. Good luck.